We are here with lesson 3.2, simplifying algebraic expressions. You are going to combine some like terms today. You're looking for things that are alike and you're going to put them together. So therefore, let's talk about some vocabulary first. That's the word term. How do I collect like terms if I don't know what a term is? A term is a number, a variable, or the product of a number and one or more variables. So if we kind of take that apart and talk about it each individually, example, a number. Okay, well, you guys know that. 7. It's a great number. Okay, variable. A variable is just a fancy way to say letter. So probably the most common letter they use is X or maybe Y. And then the last part says the product of a number and one or more variables. So maybe that is for C, or maybe it is 5x squared, or maybe it's negative 3xy. Those all individually are terms. If you had something put all together, you have something like 7x plus 4 plus y. If you look at each of those individually, you have one term here, one term here, and one term there. So that's 3 terms in that little expression, that little math sentence, so to speak. Other word we use a lot in math is the word constant. A constant is a term that does not contain a variable. So in other words, if you think about it, it's a term that does not contain a variable. Well, it says up here it was a number, a variable, or the product of a number and one or more variables. So really fancy, it's just a number. It's just a number. So another word for number they use is constant. So example, if I had this expression 4x plus 6, this 6 right here, I'm going to highlight in yellow, that is a constant. So a constant is just a number. All right, a couple other words that we need to, or terms, vocabulary terms that we need to know are the next two, and notice they're in boxes, so that tells you you're going to see it on your test. So your exam at the end of the year. So this is one you got to commit to memory. Like terms. Like terms. Like terms are terms that have the same variable factor. Terms that have the same variable factors. So you put the same variables, and I'm just going to abbreviate variables there, or constants together. Again, constants is just fancy for numbers. Together, using addition or subtraction. So you're going to add or subtract those like terms, ones that are exactly alike. So some like terms might be something like this: -6 and 8. They're both constants, they're both numbers, they're alike. You could put those together. 5x squared and 2x squared. They're both like terms because they both have an x squared. Let me pull my highlighter out. Let me change to green. Like terms would be something like this: -6 and 8. They're both alike because they're constant. Here, I'm just going to highlight the x squareds because that's what makes them like terms. They have the same variable factor. Okay, you could do 3x and -9x. Again, the same variable factor of x's on both of them. And one more example, maybe 4xy and negative 7xy. So again, the same variable variable factors of xy. Some non-examples would be something like 12x and 7n. This has an x, this has an n. They don't match. They don't belong together. 5 and 5x. Well, they have the same constant, but they do not have the same variable factor, so those would not be examples. Or maybe even like a negative 6 and 3y. This one has a y, this one doesn't have a y, so non-like terms. The next term that we need to talk about is coefficient. And of course I spelled it wrong, so let me try that again. Coefficient. C-O-E-F-F-I-C-I-E-N-T. That looks better. Coefficient. Coefficient is the number directly before the variable. The number directly before the variable. Some essential characteristics that you need to remember is don't forget to attach the sign to the number. And we'll talk about what that means here in a second. So if I had the example 5x squared minus 6x plus 4, there are two coefficients. There are two numbers directly before the variables. One of them would be 5 because it's before the x squared. The other one would be, and here you need to attach the sign, it would be a negative 6. That's what I was referring to. Don't forget to attach the sign to the number. These are both coefficients. This 4 would not be a coefficient. This 4 is just a number. It does not have a variable, so it is just a constant. So it is just a constant. So it can't be considered a coefficient. All right, so if you had the example over here in the non-example box, 7x squared plus 3x minus 5, and you had to pick out the one that is not a coefficient, hopefully you would say, right there, Mrs. Smith, it's the negative 5. It's not a coefficient. Because there is not I'm going to underline that, a variable. It has to have a variable attached. All right, those are some of the things you're going to know to be able to do some combining of like terms. If you're in class with me, we're actually going to combine like terms with some algebra tiles. But if you aren't with me in class, it's pretty hard to do algebra tiles from home because you don't have any algebra tiles. So we're going to skip over page 5 in your notes, and we're going to move right to page 6, which is a totally blank page. And we're going to move to doing all of our combining of like terms algebraically. Sounds like a big fancy word, algebraically, but it just means do it mathematically. Do it with the math and not a manipulative like a algebra tile. So write this one down. 3x squared plus x plus 2x squared minus 3 minus 2x. And so we are going to put like things together. Well, you remember from the terms, we just did like terms. And so we have to put things together that belong, that have the same variable factor. So I'm going to take my blue and I'm going to circle 3x squared. And then as you look through, you should see another 3x squared. And remember to attach that sign, just like we did with the coefficient, attach that sign. And I'm going to write those down in blue, 3x squared plus 2x squared underneath our problem, and we'll come back and do that. Well, actually, we might as well do it right now. 3x squared plus 2x squared. There are two of them. 3 plus 2, it'd be 5x squared. So now I'm going to pick up another pen, and maybe I'm going to draw a box around these. I'm going to find all of the ones with the x's. There's an x, and down here at the end is an x. I'm going to write those up and down. So I've got an x, and I have a negative 2x. Remember to attach the sign. I was very careful with my box to attach the sign first. There's nothing in front of that x, so that's that ghostly Gladys business that we've talked about before. So we've got plus 1x minus 2x. So 1 minus 2 would be a negative 1x, or just a negative x. And last but not least, I'll pick up this orange, and maybe I'll draw a triangle this time. And I just have a negative 3. That's it. So I have a negative 3, and I bring it down, and I have a negative 3. When I get done, this here is my answer I put together. So 5x squared minus 1x, or just x, minus 3. And ladies and gentlemen, you have now collected like terms algebraically. Let's try another. Number 2. Write this down. 4x squared plus 7 minus 3x plus 2x squared minus 8. So let me pull up my blue pen. I'm going to look for all my x squareds first. So I have a 4x squared and a 2x squared. So I have 4x squared plus 2x squared, which would give me 6x squared. I'm going to do my green, and I'm going to find a 3x. That's all I have to go with it, so minus 3x. And last but not least, triangles around a 7 and a minus 8, so a 7 and minus 8, which could give me a negative 1. And right there's my answer. Let me rewrite it over here. So I've got 6x squared minus 3x minus 1. I just collected like terms. Well, sometimes you don't have x squareds or x. Maybe there's something like this. Number 3. 3b plus 8b. They both have b as a variable, so we put them together. Whoops. So, whoops. There we go. Sorry about that. We have a 3b and an 8b. Whoops. Should claim that positive sign. So 3b plus 8b, 11b. Done. What if I have something like this? Number 4. What if I have 5n minus 6x plus 3x plus 4n? So go ahead and look for all my n's. I have a 5n and I have a 4n. So I put them together. 5n plus 4n is 9n. Let me pick up a green. I have a negative 6x and a plus 3x. So negative 6x plus 3x, and that would be negative 3x. I just noticed I wrote a squared on there. There's not a squared, it's just an x. Now, when I go ahead to write these, one thing I want to point out is when you have different variables like an n and an x, you list them alphabetically. So how they come in the alphabet? Alphabetically. I-C-A-L-L-Y. There we go. Alphabetically. Boy, I'm not a speller. All right. So n comes before x in the alphabet. So you would write 9n first minus 3x. All right. I think that gives you some to work on. When you're writing up here, maybe I should have added 2. You go in order of the exponents. So this exponent is x squared, so you have x squared, and then you have an x, and then you have no exponent. So you always go in decreasing order. So if there was an x to the third, you'd go 3, and then 2, and then actually if there's nothing there, that's that ghostly Gladys 1, and then a no exponent. So that's how you would list them up there. All right.